So good morning, friends. I'm Neeraj Gupta, and we are continuing this lecture on signal conditioning and data acquisition systems here for the fifth unit of electrical measurements and instrumentation circuits. So till now, we have talked about the various signal conditioning processes. So first, we have talked about filtering. Then we have talked about that is amplification. Now and linearization. Now we are talking about this isolation. This is the fifth process. So signal conditioning equipments can also be used to provide the isolation of transducers. Without isolation, what will happen? The interferences of signal takes place. The signals from the computer where there is a possibility of high voltage transients may occur within the system being monitored, either due to electrostatic discharge or could be an electrical failure. So because to avoid this type of situations, the isolation is being done. It protects the expensive computer equipment from damage and computer operators from injury. In addition, where common mode voltage levels are very high, or there is a need for extremely low common mode leakage currents, for example, the medical equipments, where isolation is very required because the inputs are or voltages are three-phase supplies. So if any of the inputs currents is leaked, then it could cause a traumatic condition for the patient. So isolation allows the measurements to be done accurately, safely, and isolation of the signal source is very crucial where there is a risk of high voltage transients by electrostatic discharge. Either it could be lightning, it could be high voltage equipment failure. These are the possibilities where these isolations are very much required. These transients or high voltage lightnings can ruin the expensive DAQ equipments if they are not isolated from the signal source, and may also cause serious injuries for humans which are handling them, those are handling these equipments. Also, using the isolation prevents the complexities caused by the common mode voltages, and ground systems isolations can be carried out in these following ways. By using the isolation transformers, these are the ways, very common ways in which we isolate the common mode voltages. By using the buffer amplifiers to isolate the input signals from the ground noise, by isolating the systems, or using the ground references. So these are very common ways in which we isolate a high voltage carrying circuit from the computer systems, or you can say our data acquisition systems. Then comes excitation, another process of signal conditioning. The transducer generally provides the excitation signals required by the data acquisition hardware and for data manipulations. However, in some cases, the transducers require external excitation from external sources due to weak signal generation, non-electrical signals generations, or due to noise interferences and other factors. The signal conditioning hardware provides such type of excitation signals where the transducer, which converts the non-electrical values into electrical values like voltages and currents, signals are known as active transducers. Within the self, if they are getting that energy without any biasing and or any other thing, those are considered to be as active transducers. The transducers do not generally require external excitations, while other devices, which are known as passive transducers, requires the external biasing. For example, LVDT is an example of passive transducer. Piezoelectric crystal thermocouples are the examples of the active transducers. They do not require any external biasing. So, they do not generally require external excitation. Other devices, which are known as passive, requires the change in electrical network value, such as either could be a resistance, could be a inductance, could be a capacitance, according to the changes in the physical quantity. The example of passives are strain gauges, that is resistive, where resistance changes to stress, and LVDTs, inductance changes into the displacements, are the two examples of passive transducers. To be able to detect such changes, the passive devices or passive transducers requires the external excitation. Now comes the most important part of the lecture, is the data acquisition system. What this data acquisition system is, or as the name is telling, data acquisition, that is collection of, acquisition means collection of data. Acquisition is collection, and collection of data. Data acquisition system is a specific device or a complete integrated system which is using which have been used to collect the information about the conditions or various states of the parameters of any particular process. Nowadays, various data acquisition systems are integrated with computers, sensors, signals conditioning devices as a one. The function of these kind of data acquisition systems varies for simple recording of process parameters to control the industrial systems, for actuation, for analysis, for preventive maintenance. These are the particular uses. These kind of systems basically have a hardware. There will be a complete hardware and the software part as well. Both will be the part of the data acquisition system. The hardware part consists of a sensor signal, signal conditioning, A to D converters, memory, processor, switches, digital to analog converters, and many other parts could be there. And the software part basically consists of operating system, editor, graph display program, data processing software, or could be many more things. But basic components are these only. So as a definition, if we do provide it to, so data acquisition is the process by which a physical phenomena from the real world are transformed into electrical signals that are measured and converted into a digital format for further processing, analyzing, actuation also, and storage by a computer. So this is the basic definition that we are having about the data acquisition systems. So the use could be, it could be for processing, analyzing, storage of a computer, and also I told you one more, that is actuation of any other system using that. Now if we talk about the basic components of data acquisition system, as I have already discussed few things about this. So first part, the data will be taken from a sensor or a transducer, then could be a field wiring, then signal conditioning, data acquisition hardware, the personal computer, and the operating system. So these could be the major components of this data acquisition system. So if we talk about the particular block description of this data acquisition system. So this is a physical world where physical quantity of any nature will be measured. This is a physical world where sensing will be given, done by transducer, a sensor. Then along with that, if that particular value which has been sensed by transducer or sensor, if that is not in a measurable range, that is not particularly filtered out, having interferences, noises, then that needs to be done with the signal conditioning block. There needs to be A to D conversion. Why A to D conversion? Because the signals which are coming over here are analog in nature. These analog signals directly cannot be fed to the computers or the digital systems. So digital systems in feeding can only be done after their analog to digital conversion. Then after they are fed, the processing is being done, their display could be done, their decision making, using them, the decision making could be done. Then afterwards, if we require that signal to actuate something in physical real-time work, then the D2A conversion needs to be done. The output which have been, the decision which have been made, the decision is to be made, has been fed to D2A converters, converted into again analog output from digital. Then further signal conditioning requires to make it suitable so that actuation could be done, because actuation is a process of any actuator. Actuator physically changes the position. It could be a motor, it could be a relay, or it could be anything which changes a physical state. So that is, the process is known as actuation, and that in real time will be given to the real world. So if we talk about example, a physical phenomena, it was temperature as we have taken, or motion or pressure, anything we can take is analog in nature. We can give it to a sensor. For temperature, we can give it to a transducer like thermocouple. For pressure, we can give it to a transducer like strain gauge. Output of these sensors could be a noisy signal which have been fed to field wiring. It is a noisy signal. It is noisy electrical signal. Further requires this conditioning, where filtering, amplification, linearization, and many other aspects which we have talked about previously for signal conditioning needs to be done. So there are filters and amplifiers. Then filtered and amplified, this is a smooth signal which have been at the output of signal conditioning block. So filtered and amplified signal is fed to this data acquisition hardware. Also, we need to have A to D converters after this, because here we are feeding it to a data acquisition hardware, and data acquisition hardware so provides you the digital format of that. Actually, as we have talked also, if we are not having A to D here, the D2A needs, data acquisition system needs to have the A to D converter facility in itself available. So these are the major components of a data acquisition system. So data acquisition hardware basically is having the main function of the hardware is to convert analog signals into digital and to convert the processed digital signals into analog signals. Sensors and actuators, what are the functioning? The transducer converts the input energy from one form to another form. Like thermocouple converts heat energy into electrical. An actuator also converts energy from one form to another. But actuator, what is the functionality of actuator? It is taking output from a D2A converter and a signal conditioning block. And in order to actuate a process, what it is doing? Based on the decision which have been made at data acquisition hardware, it will particularly implement that decision. The decision has been made to operate a switch or to do a relay or to a motor. So that particular function is being implemented with the help of the actuator. Then signal conditioning hardware. Signal conditioning hardware basically, sensor signals are often not compatible with the data acquisition hardwares. To overcome this inoperability or incompatibility, the signal must be conditioned first. For example, we may need to condition the thermocouple output signal by simply amplifying it or by removing the unwanted frequency components. The output signal may also require conditioning. So these are the description of these components. The remaining components are computer. Obviously, it would be having a processor, a system clock, a bus, transfer data, a memory, a disk space for storing. Then there will be a software, operating system for that computer. For example, typical softwares are describing the sampling rate. Our board acquire a predefined amount of data. At what rate it will be sampled, how it will be converted into a digital domain. That all things needs to be done by the software itself. So these are the references for the courses that we are discussing over here. As a part of data acquisition system, we are also referring some other books like S.K. Singh, Nakra and Chaudhary, Instrumentation Systems by Nakra and Chaudhary, and some Doblin is another book which is very good for reference purposes. So data acquisition systems, signal conditioning, and the components of data acquisition systems have been discussed in these lectures. So let's hope the topic gets clear to everyone. Thank you.